Hi, I'm Clay Brown. Today we're going to be talking about voltage drop testing here at the training center, and we're going to start out by kind of getting you guys up to speed on where we're at with the process. We have a very simple series light circuit here that's set up. We've got 1 meter here that's reading amperage, and we've got another meter here that's reading voltage. Taking a look at our board over here, we collected these readings doing some previous testing, and we want to point out a couple of things to you. You notice that we have a difference in current here, and of course we have two different resistance readings. This is what we calculated the current to be when we measured our resistance of the light bulb when it was off. When we actually powered the light bulb up, we measured our 0.174, which is what we see on our meter right now. We see this reading on the meter. So this is our actual value. We did, of course, a little bit of math again, and we came up with this bulb, when it's running, has 70 ohms of resistance. Well, things changed in the circuit. Things changed because of the temperature, of the light bulb. The current flowing increased the resistance in this light bulb to 70 ohms. Now, why is that important? Because again, remember, if we have a bad wire or a bad connection or something happens, that relatively low reading you get for ohms, once that current starts flowing in the circuit, can increase dramatically. So rather than using resistance readings to find problems in electrical circuits, we want to use voltage drop testing. It's far more effective and a lot easier to use. So let's run through pretty much what we've got here. I've got a powered circuit working. I've got my meter set here for volts and DC volts. I take my meter leads, and of course the first step in voltage drop testing is to measure the volts of the source. So we're going to connect our meter leads up, and we're going to take our reading, and of course we now have 12.22 volts of available voltage for this circuit. Now, okay, so we're off 1/100th of a volt. That's not a make or break deal on all of our calculations. The next step in voltage drop testing, once we have the volts of the source, we apply something called Kirchhoff's law for voltage. Kirchhoff's law says that the sum of the volts are dropped at the load. So, the volts are dropped at the load in this circuit. The load is the light bulb. Let's go to the light bulb and let's see if Kirchhoff is right and all of our voltage is in fact dropped here. What do we get? I've got 12.17. So again, I went from 12.22 to 12.17. I have a difference of 50 millivolts. Not very much, but what that indicates is resistance in the circuit. If it was perfect and it was working, it would be exactly 12.22. Now, is this okay? There's our next thing that we have to establish. In this particular circuit, yes it is. We're dealing with a circuit with multiple connections in it. The allowable voltage drop for a circuit like this, rule of thumb, is about 500 millivolts. So that's 0.5. We are nowhere near having a bad circuit. But out of curiosity for our voltage drop testing, let's see if we can find out which side of this circuit is the culprit that's taking our 50 millivolts. Is it our ground wire going back? Or is it the other side of our circuit where we go through a switch, a fuse, several wires, the meter, and everything else? So for voltage drop testing, it's very simple. We're going to take our positive lead, We're going to test the positive side of the circuit. We go to the battery. Now don't be confused, when you go to the battery, we mean go to the battery. You're going to the post, not the terminal that's clamped to it, the post itself. Your other meter lead comes over here to the positive side of our light bulb. And of course we take our reading. Have we found our missing voltage? Well, yes, we did. Miraculous. Exactly the right amount. Take and measure the other side. I'm taking my positive lead and I'm coming here. This lead is going to go to, again, the ground post on the battery, and it should be pretty close to 0. And it practically is 0.002. So, hardly any voltage on the ground wire, and of course we found our missing voltage that wasn't dropped at the load for the light bulb. Good exercise. We did find it. We can't measure resistance in a powered circuit, so this is an effective way to use a dynamic reading to find problems in a circuit. But this circuit has no problems. Thank you for watching today. Hope you come back, and I hope you're successful with troubleshooting your circuits.